All right, so today we are going to be starting Unit 5. In Unit 5, we're going to be talking all about what are called polynomials. Polynomials are really just kind of an extension of what we saw in Unit 4, where we were talking all about quadratic functions. So a lot of the same stuff that we did with quadratic functions is still going to apply to polynomials. We're just going to get into a little bit kind of more complicated cases, a little bit larger cases, a little bit more broad generalization of what quadratics can do. So polynomial, first off, definition is it's a combination of coefficients and positive powers of x. So to give you some examples of that, any quadratic is a polynomial. So x squared would obviously be a polynomial, but we can also expand that to some higher degree polynomials. For example, x cubed plus 2x plus 1 would also be a polynomial. Also, x to the 7th power plus 4x would be a polynomial. In fact, you could even consider numbers to be polynomials. Now, oftentimes, we won't really consider numbers to be polynomials, although it is something that you could do if you really wanted to. So let's focus now on some non-examples, so some things that would not be considered polynomials. Obviously, polynomials have to have positive powers of x, so x to the power of negative 2 is not going to work. Also, those positive powers of x need to be whole numbers. So fractions are not going to work. X to the power of 1/2 would not be a polynomial. Now, x to the power of 1/2 is really just the same as the square root of x. So anytime you got a square root sign or a cube root sign or anything like that over the variable, then that's not going to be an example of a polynomial. However, it is worth pointing out that something like the square root of 2 as a coefficient for a variable, so the square root of 2 multiplied by x, actually would be a polynomial. Now, we're not going to look too much at polynomials with non-integer coefficients, meaning coefficients are numbers that are not whole numbers, but it is possible to have that as a polynomial. Also, you cannot have variables in your denominator. 1 over the power of x would not be considered polynomial. It would actually be the same as x to the power of negative 1, and so then that would not have a positive power. And finally, you cannot have variables as exponents. So obviously, 8 to the power of x would not be considered a polynomial. Now, when we talk about polynomials, we're going to classify those using some different terms. The first thing that we're going to do in order to classify a polynomial is we're going to write it in standard form. So a standard form polynomial is just a polynomial that's written from its highest to lowest degree. What I mean by degree is the exponent. So to give you an example of that, 4x to the 3rd plus 2x squared plus x plus 5 would be a standard form polynomial. Notice that your exponents go from 3 to 2 to 1 down to, well, really 0 for that last term. The leading coefficient then is just the coefficient of the highest power of x. So in that example that I gave to you, the leading coefficient, which we sometimes abbreviate LC, would just be the number 4. Now, when we classify polynomials, we do that using kind of a two-name structure. I'll compare this to in science or biology, where you would name different organisms by their genus and their species. For example, humans are Homo sapiens. And I won't try to name any other ones, but we do kind of the same thing when we classify polynomials. We use kind of two different names in order to classify those. The first is based on its degree. So if it's got a degree from 0 up through 5, really we won't look at too much that's higher than 5. You see the classifications there. So 0 is constant. An example of that is really just a number. For a degree of 1, that's any linear function, pretty familiar with those, 3x plus 2 or something like that. The degree being 2, we obviously spent quite a bit of time with that last month. That was a quadratic function, so something like x squared plus 5. For 3, you have a cubic, so x cubed plus x plus 1. For the 4th power, we call that quartic, and then for the 5th power, we call that quintic. For the number of terms, we also have a classification. If it's got just a single term, we're going to call it a monomial. So an example of that would just be 2x to the third. So you just have one term. Now, obviously, multiple parts to that is okay, but you're not adding or subtracting anything from it. The second for two terms is called a binomial. So you could think about like a bicycle, two wheels, has two terms. X plus 7 would be an example. For three, trinomial. So again, you could think about a tricycle has three terms, or three wheels for a tricycle. So a trinomial has three terms. So that would be something like x squared plus x plus 1. And finally, when we get to four or more terms, we're just going to call that a polynomial. I guess we could say a polynomial with blank number of terms. So anytime it's four or more, we'll just kind of use that for our classification. Okay, so let's do some practice with writing polynomials in standard form and classifying. So starting with writing them in standard form, we need to write them from highest to lowest degree. So looking at example A, we've got 7x squared plus 3x cubed minus x. Our highest exponent is going to be x to the third. So we're going to start by writing this 3x to the power of 3 term first. Our next highest exponent then is x to the power of 2. So we'll put a positive 7x squared after that, so a plus 7x squared. And then we'll put our minus x, which would be x to the first power, at the very end. Okay, let's move on to example B and write its standard form. So highest exponent would be x to the fourth. So we'll write that first, 9x to the power of 4. Next highest is x to the power of 2. So we'll put a plus 5x squared after it. Next would be x to the power of 1. We actually have two different terms with x to the power of 1, so we need to combine those together. Negative 3x plus 3x actually add to be 0. So then 9x to the fourth plus 5x squared is just how we'll leave our standard form. Finally, for example C, we've actually already got it in standard form, so that would just be 5x plus 1. All right, let's next name these by their degree. So our highest exponent in standard form, for example, A is a 3. And so if it's got a degree of 3, that's going to make this a cubic polynomial. Next, for example B, notice that our highest exponent is a 4. So that's going to be a quartic polynomial. Finally, for example C, we've just got our highest exponent as a 1. That's going to be a linear polynomial. All right, let's next name each of these by their number of terms. So for our number of terms on example A, we've got 3 different terms that we are looking at. So that would be an example of a trinomial. So the entire name, the full classification for example A, would be a cubic trinomial. Next, for example B, we just have 2 terms there. So that would be an example of a binomial. So the full classification for example B would be a quartic binomial. And C would actually be the same. It has just 2 terms. So C would be a linear binomial. Finally, let's go ahead and write down what the leading coefficients would be. Our leading coefficient, for example, A is going to be the number 3. Our leading coefficient, for example, B is going to be the number 9. And our leading coefficient, for example, C is going to be the number 5. All right. In addition to classifying, we are also going to talk about the first 2 operations today, which are adding and subtracting. In later sections, we're also going to talk about the other 2 operations. We're going to talk about both multiplying and dividing polynomials as well. But for today, we're going to focus just on adding. Now, in adding, we can also write it using kind of a special function notation. If we wanted to do that, f plus g of x is the same as taking f of x plus g of x. In other words, you're just adding the 2 functions together. I think we actually saw this a little bit in Unit 1, but it's worth reviewing as well. So the same would be true for subtracting polynomials. If you have f minus g of x, that would be just taking f of x minus g of x. So once again, you would just be subtracting your two functions. And so really what adding and subtracting comes down to is it's just combining like terms. Now, when we write our final answer, we do want it to be in standard form. So to practice that, here's what makes it kind of easy. Let's take a look at example A. We're going to look for the highest exponent for our variable. So for our variables, it looks like the highest exponent is going to be powers of 3. We've got negative 8x to the power of 3 and negative 3x to the power of 3. If you combine those together, negative 8 plus negative 3 is going to be negative 11x to the power of 3. Then you look for your next highest exponent. So obviously x to the power of 3, the next highest would be x to the power of 2. And it looks like we've actually got 3 of those that we need to combine together. If we take negative 9 plus 8 is negative 1, plus 4 is positive 3. So that's going to be a positive 3 x to the power of 2. Next, we'll look for just x to the power of 1. So we've actually got 2 of those to combine, a positive x and a negative 2x. So 1 minus 2 is going to be negative 1x, so a minus x. And then finally, we'll do just our constants. So 2 plus 4 is 6, minus 1 is positive 5. And again, if you do it that way, kind of nice, because notice that really you're done. You've already got it in standard form. You're from highest exponent to lowest, and you're good to go. All right, so example B is essentially the same idea, just using our notation. So remember, f plus g of x, we're just taking f of x plus g of x. And I won't write it out all this way all the time, but just to kind of belabor the point, what you're going to be doing is taking your function for f of x and substituting it in. So 6x squared minus x plus 3. And then we'll do the same thing for g of x. We'll substitute its values in. So negative 2x plus x squared minus 7. All right. So now really what it becomes is just like example A. We're going to look for where's our highest exponent and add those together first. In this case, that would be x to the power of 2. So we're going to take 6x to the power of 2 plus x to the power of 2 is going to be 7x to the power of 2. Next would be our x's, so negative x plus negative 2x is going to be a minus 3x. And then finally our constant, so 3 plus negative 7 is going to be a negative 4. All right, let's take a look at a couple more examples of addition, and then we'll get to subtraction. So in our next example, once again, we're going to look for highest exponent, which in this case is powers of 4. If we take negative 4 plus negative 3, that's negative 7x to the power of 4. Then we'll look for our next highest exponent. In this case, that would be x cubed, but we don't have any. So we'll jump to x squared. So we've got 3 minus 14 is negative 11x squared. Our next highest would have been x, but again, we don't have any. So we'll go to our constants. So 14 minus 8 is going to be positive 6. And there is our final answer. All right, so in example D, I'm not going to write this one all the way out. Refer to example B, but we're really just adding these two functions together. So we're taking f plus g of x. So we're looking for where's our highest exponent. That's going to be x squared. So if we take 2 plus negative 1, that's just positive 1x squared. Next highest is just for x, so negative 4x plus 2x is going to be a minus 2x. And then finally, negative 8 plus 3 is going to be negative 5, and there's our final answer. All right, so that's addition, pretty simple. Subtraction is going to be much the same. The only difference being that you're going to have to be careful with the minus sign. In fact, what I'm going to choose to do on each of these problems is distribute the minus sign to change it to be an addition problem. And then it really just works the same as the examples above. So let's see kind of how that works. On example A, what we're going to do is take our minus sign and distribute to each of the terms in that parentheses that follows it. not the ones in front. Obviously, the negative 6x to the third plus 5x minus 3, we can just copy down. Nothing's going to change there. And really what that's going to do is make all the values opposite. So the positive 2x to the third is going to be a negative 2x to the third. Positive 4x squared is going to become negative 4x squared, and so on. So a plus 3x and a minus 1. And now we just do addition like normal. So we look for our highest exponent, which is powers of 3. Negative 6 plus negative 2 is negative 8x to the power of 3. Next would be x squared, nothing to combine it with, so we'll just copy that down, negative 4x squared. Next would be our linear terms, so 5 plus 3 is 8x. And then finally our constant terms, negative 3 minus 1 is negative 4. All right, now example B, I'm going to go ahead and write out just so we can see it. So in example B, a little bit different. We're taking f minus g of x. Remember that is the same as taking f of x minus g of x. So when we write that out, again, we're going to take f of x and substitute what it is equal to. So that would be the 12x minus 8x squared plus 6. And then do the same with g of x. So substitute in the negative 8x squared minus 3x plus 4. And then we'll go ahead and work this just like we did example A. So we're going to take our minus sign and distribute that. So that's going to be a positive 8x squared, a positive 3x, and a minus 4. Remember the first parentheses, we're just going to copy down. Nothing's going to change there. And now we should be ready to work this just like any other addition problem. So looking for our highest exponent, it's going to be powers of 2. In this case, negative 8 and positive 8 add to be 0, so those are just going to cancel. Next, we'll take 12 plus 3, which is 15x. And finally, 6 minus 4 is positive 2. All right, let's take a look at 2 more examples, and then we should be done with this section. So in our next example, again, we're going to kind of start it the same way. Let's go ahead and distribute our minus sign. So that's a positive 2x squared, a positive 3x cubed, a positive 4x, and a negative 5. Again, the first parentheses, just go ahead and copy down. Nothing to change there. All right. So let's go ahead and combine our like terms. So our x to the thirds, kind of like on example B, actually add to be 0, so those are going to cancel. Next, for x squareds, those are not going to cancel. 2 plus 2 is, in fact, 4x squared. Then for x, we just have 4x, so we'll go ahead and copy that down. And finally, for our constants, negative 7 minus 5 is negative 12. All right. So for example D, again, I'm not going to write everything out. Refer to example B to kind of see how this works. I'm going to go ahead and do this to write out just a little bit. I'm going to go ahead and copy down what f of x is. So x squared minus 3x minus 7. For g of x, since we're subtracting g of x, I'm going to go ahead and change these to being their opposite values. So negative x squared becomes positive x squared. Positive 2x becomes negative 2x. And now I'm ready to go ahead and combine like terms. So x squared plus x squared is 2x squared. Next, we've got negative 3 minus 2 is negative 5x. And the negative 7 is all by itself, so we'll just copy that down. And here's our final answer. All right, guys, so that is it for this first section of the notes. In the next section, we'll be talking about multiplying polynomials, where some of this work with addition and subtraction will come into play. Until then, have a good rest of your day.